when you have two variables in a quadratic inequality, you're going to have four different cases. So when I say two variables, I mean you have a y and you have an x. So in the other examples, all we had was an x, and then we had that it was greater than or equal to, or less than or equal to, or greater than or less than 0. Okay, instead of 0 now we have a y. So we're just going to graph these, but now we have the four cases where it can be greater than or equal to, just greater than, less than or equal to, or just less than. So here's an example of what we need to do. So you're going to graph the solution to this function, okay? So first thing we have to do is we have to graph it. We want to find our vertex, and we want to find whatever points we can find. So it's in vertex form. So I can find my vertex right away. And the vertex, remember, is the opposite of what's inside. So my vertex is going to be a +2, and then exactly what's outside. So 2, 1. I'm going to just pick 0 for x. If I plug 0 in, 0 minus 2 is -2. -2 squared is 4. 4 plus 1 is 5. Okay, and then because of symmetry, if I take 4, 4 minus 2 is 2. 2 squared is 4. 4 plus 1 is 5. So I have 3 points that I'm going to use. So I'm going to graph the related equation. So let's start to graph it. And it says use the vertex and 2 other random points. So that's what I found. And then it says solid line or dotted line. So that has to do with our inequality symbol. If it has the line underneath it, you're going to draw a solid line. If it doesn't, you're going to draw a dotted line. So this one is going to be a solid line. So I'm going to graph my 3 points. So I have so 2, 1 is my vertex. I have 0, 5, and 4, 5. I'm going to draw a solid line, so my parabola is going to be solid. Okay, so then we're going to test 0, 0 to see if this point satisfies the inequality. So 0, 0 is over here. If I plug 0, 0 into my equation for x and for y, okay, I'll have 0 is greater than or equal to 0 minus 2 squared plus 1. So 0 is greater than or equal to 5. Okay. If that's true, we would shade that part in. So 0 greater than or equal to 5, no, that's not true. So 0, 0 doesn't work. So we want to now test a point inside the parabola. Okay, 0, 0 was outside of the parabola. Didn't work. So if we test the point inside, that should be true. So if we test, let's say this point, and it's the point, let's do 2, 4. So 2, 4. Let's use that point. So we're going to plug in 4 for y. So 4 is greater than or equal to 2 minus 2 squared plus 1. So 4 is greater than or equal to 1. That's true. Okay, since that's true, you shade in the region that is true. So it's true inside the parabola. Okay, so we shade in the correct area. And another way to think about this is if you look at the symbol, if it's greater than, you're shading inside. If it's less than, you're shading outside. So this is for a parabola that opens up. So greater than means up, and less than means down. So since I'm shading in something that's greater than this, it should be inside the parabola. Now you can always pick a point and test it. 0, 0 is an easy point to test. If you test it and it's true, you shade in the part that's true. If you test it and it's false, you shade in the opposite part. So you're either shading in inside the parabola or outside the parabola. Okay, so let's look at this example. So graph the solution. So first thing I want to do is pick our points. So I'm going to use the vertex, which is -2, -3. Okay, I'm going to plug in 0 since that's easy. 0 plus 2 is 2, squared is 4, minus 3 is 1. And because of symmetry, the other point I can use is -4, 1. And I know this because the vertex is in the middle. So if I go 2 to the right, I'm at 0. If I go 2 to the left, I'm at -4. So let's graph this. so I'm at -2, -3 for my vertex. I have 0, 1, and I have -4, 1. If I look at my inequality symbol, it's just less than. It's not less than or equal to. So I'm going to have a dotted line. So my parabola is going to be dotted instead of solid. Okay, and then I want less than. So since it's less than, it should be outside the parabola. So let's test the point. So the point that's outside the parabola is 1, 0. So let's test the point 1, 0. So when we plug in 0 for y, it's less than 1 plus 2 squared minus 3. So 0 less than 3 squared, which is 9 minus 3. 0 is less than 6. That's true. Since it's true, I'm shading in the outside of my parabola. Okay, and again, the little shortcut is it's less than, so you're going to shade out. If it's greater than, you're going to shade in. Okay, and let's look at another one now. So, same idea. Okay, we're going to graph this. So, we need to know the points to graph. So we can do our factoring for this to get our intercepts. So I can use x minus 6 and x minus 2. So x equals 6 and x equals 2. So I have 6, 0, and then I have 2, 0. Okay. We can find the vertex, or we can use the y-intercept. So you can use 0, 12 for your y-intercept, or you can do negative b over 2a to find your x. So that would be 8 over 2, which is 4. And then plug that in for y. So 4 squared minus 8 times 4 plus 12. So 16 minus 32 plus 12. So negative 16 plus 12, which is negative 4. So 4, negative 4 is our vertex. So you can use whatever. You need 3 points. You can use a combination. Okay, so let's graph this. So I'm going to use 2, 0 and 6, 0. And I'll use 4, negative 4. Okay, this opens up since a is positive, and because of my symbol, it does not include it, so I'm going to have another dotted line. So my parabola is dotted. Okay, and since it's greater than, it should be inside the parabola. So let's use 0, 0, because it's easy. Okay, if I use 0, 0, this should be false. So let's plug it in. 0 is greater than 0 squared minus 8 times 0 plus 12. So 0 is greater than 12. That's false. So since 0, 0 is outside of the parabola, and that's false, we shade the opposite. So we're going to shade the inside of the parabola. Okay, so any point in that shaded region will be a solution to this.